I knew you'd be back. You could not stay away. You're like, this is awesome. You ready? You've been on the edge of your seat for hours now, waiting for this moment. I need to tell what charge the iron is using. It can use, according to my periodic table, and many of the transitional elements can use more than one charge. Positive 1, a positive 2, positive 3, positive 4, and some of them can use all kinds of them. And you got vanadium here. It's got like positive blah, 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 blah. Vanadium, come on, make up your mind. Schizophrenic. But there are some elements in the center section that only use one charge. For example, silver only uses the positive 1. But we're going to make the assumption if you fall into this transitional group, or these rare earth elements, that you have the ability to use many charges. So calcium, or iron, can use either a positive 2 or a positive 3. And we have to figure out which one it's using. Let me write that a little bit bigger. I know you're straining your eyes at this point. So it can use a positive 2 or a positive 3 charge. Which one is it using? The way you figure that out is you look at the negative ion. Chlorine is the negative ion. It's the non-metal. Those are negative ions. So the non-metal will lead you in the right direction. I have 3 chlorines. I do, Cl3. And I know chlorine always, always, always uses the negative 1 ion. It's going to be a negative 1. Remember I gave you that other periodic table. This one actually has like too much information sometimes. But I give you the other periodic table where on top of that group, I put negative 1. That's the negative 1 group. Chlorine's a negative 1 ion. So if chlorine is a negative 1 ion, and I have 3 of them, that gives me a total of negative 3 negative charge. So I have a total charge on the negatives of negative 3. 3 times negative 1, each chlorine's negative 1, is a total of negative 3. Nature loves balance. You gotta have things balanced or nature's gonna freak out on you and it will balance it. So if I have a compound, iron and 3 chlorines, I have to have positive and negative balance. There has to be a neutral overall charge of the compound. So negative 3 has to be balanced by positive 3. Has to be balanced by positive 3. All right, now there's only 1 iron. If there's only 1 iron, what does it have to have for a charge to balance the negative 3? Positive 3. In this case, iron has to be using the positive 3 charge. This is what's going to give some students trouble, is trying to figure out the charge of the positive ion. And I'll go through a couple of these so we can, hopefully you'll get it. And if it doesn't work for you, rewind, go through it again. All right? So I know that the iron is using a positive 3 charge because there's only 1 of them, and it has to balance the total of negative 3 charge produced by the 3 chlorines. So why would I name this compound? I would name this, let's write this in a different color, it stands out. I would name this iron. Now, it says determine the metal's charge and use Roman numerals. I use Roman numerals to indicate the charge. So this is iron 3. You put Roman numerals. You don't have to put the parentheses. I do that. Sometimes you'll see it and sometimes you won't. Sometimes you'll just see iron 3, and that's fine. Iron 3 chloride. All right, iron 3 chloride. All right, so you still use the IDE ending to the compound. So iron 3 chloride. Iron 2 chloride would be FeCl2. That is a completely different compound. If I ask you, what's iron oxide? Some of you will go, it's rust. Iron oxide is rust. Yeah, true, it can be rust, but there are other compounds that, there's iron FeO, and then there's FeO, and then there's Fe2O3. Those are both iron oxides, but they're both completely different compounds. One's rust, okay, got that brown rusty color, and one's not. One is black, and those are completely different things. So I say, go to the chemical cabinet and give me some iron oxide. Hopefully you go to the chemical cabinet, walk over there, open it up, and go, okay, which one? Because there are 2 of them, 2 iron oxides. See, we got to know which one. So we have to put the charge of the positive ion, if it's in the middle of the periodic table, we have to put that in parentheses. Now, there are going to be a couple. Chemistry is the science of exceptions. There are general guidelines, and there's always exceptions. There are 2 metals which you need to know. That's tin and lead. Can you see those? Tin and lead. very common metals, very important common metals that aren't in, that's in the right side, this right block here, those aren't in the transitions, but they have multiple charges. So there are some exceptions to these guidelines. So you could, like tin or lead, be outside of that transitional block and still have multiple charges. They can both use a +2 or a +4. So we have to be aware of that. And I also wrote them down for you at the top of that periodic table in the middle. Put the lead up there, +2, +4 possibility. Okay, let's keep going. Some more problem twos. It takes a long time. Okay, people, naming takes a while. Writing, which is the opposite, easy, because you've been dragged through the mud on this, and it's a lot easier, but naming can take some time. All right, so let's try number 1. BaOH, parentheses around the OH, 2. Barium, okay, so it's got Ba, it's got O, it's got H. BaO and H. Is it binary? No, it isn't. Is the metal in the middle of the periodic table? Barium is not. Okay, barium is over it's in the alkali earth metals. So name the polyatomic. If you memorize your polyatomics like I told you to, you would know OH is hydroxide. It's one of the important ones. You need to know that. So that would be barium hydroxide. Okay, just a kind of a review of something we've gone over. Let's check out 14. FePO4. FePO4. Name it. Is it binary? 9. No. 1, 2, 3 different elements. Not binary. That means there is a polyatomic ion. Doggone it, you gotta know. Is the metal in the middle of the periodic table? The metal. Iron. Is it in the middle of the periodic table? It is. We just did this. Yeah, that iron is in the middle of the periodic table. So this time we have to go, and finally we've used all the chart now at this point. We will get this out of here. Is the metal in the middle of the periodic table? Yes. Determine the metal's charge, use Roman numerals. So this is the same thing as over here. If we have the metal in the middle of the periodic table, whether we have a polyatomic ion or not, we still have to do the same thing. We have to figure out the charge the iron is using. Okay, this is what you know it, I hope. Look at it, find it. Phosphate, yes, this is phosphate. And we know its charge, look at, see it? -3. This whole thing, the whole phosphate here has a -3 charge to it. That whole thing, -3. Nature likes balance. So what does the iron have to be using? The iron has to be using a +3 to balance the -3 of the phosphate. So +3. This is iron 3 phosphate. Okay, iron 3 phosphate. All right. Whew. Where was my sheet? Where's my sheet? Where's my sheet? All right, let's try number 11. Number 11. That looks like phosphorus and oxygen. P2O5. What do we got? Is it binary? Yes. Phosphorus and oxygen? Yes. Is there a metal? Phosphorus and oxygen? No. Phosphorus is on the right side, not a metal. So use prefixes, add IDE. Okay, one more prefix try here. How do we do this? Use prefixes. Diphosphorus, pentoxide, pentoxide. Not pentaoxide, because that would be 2 vowels back to back. No. So we drop the A on the pent, drop it. Diphosphorus pentoxide would be how we name that compound, diphosphorus pentoxide. All right, let's try another. How about number 7? Right there. Oh, my thumbs. Oh, that wasn't good. Okay, 7. Okay, that one says PbSO4. 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 Is it binary? Lead, sulfur, oxygen? No. It's got a polyatomic. okay, is the metal in the middle of the periodic table. If you look at lead, I pointed this out just a few minutes ago, lead is an important exception. Is it in the middle of the periodic table? No, it's in this square block over here. Actually, for future reference, it's called the P block. So the answer is no, it's not. Chemistry is an exception science. So here's one you just got to know. Lead has multiple charges, but it's not a transition element. So we would have to be careful with this one. If you see lead or tin, be careful, because you are going to have to use Roman numerals. So this one is lead and sulfate. Sulfate, we all know our polyatomics, has a -2 charge. Now, that's one sulfate. That doesn't mean 4 sulfates. That's 4 oxygens in the sulfate. So it's one sulfate. All right? Has a -2 charge. There's one lead. Must be using a +2 to balance the -2. So this has to be lead 2 sulfate. So lead 2 sulfate. All right, lead 2 sulfate. I'm going to do one more, and we're going to wrap this naming up. I think we've done. Now I'm not going to do every one on these 2 sides of the sheet. What I will do is for next week, I'll load in the answer key for you. So you try the rest of them. I will give you the answers, and then you go through them, see how you did. And if you have any questions, tune in to one of our Zoom sessions and ask. All right, so we'll go through one more. Let's do level 2. One more. One more. That's Rosie. That's Rosie the robot on the Jetsons, okay? We all remember watching the Jetsons when we were kids. Rosie the robot. She was lovesick. Okay? All right, check it out. That's awesome. Go Zoom it. Or not Zoom it. What do you call that YouTube thing you always watch? YouTube. Go YouTube it. Rosie the robot. Okay, moving on. Let's get one more done. Let's try number 17. It says, see you later. No, it doesn't say. See you, CO3. See you. I know a lot of you are wanting to say, see you later. Is it binary? 1, 2, 3, no. Is the metal in the middle of the periodic table? That's copper. Copper's a metal. You know copper's a metal. The answer is yeah, it is in the middle of the periodic table. It is one of the transition elements. It's right here. And above it here, it says a 2 or a 1. Copper can use a +2 or a +1 charge. You can use either one of them. So I need to know which one it's using. All right. This right here is carbonate, one of the polyatomic ions. You need to know carbonate. And it has a -2 charge. So that whole thing there is carbonate, -2. So the copper, only being one copper, has to balance the -2 with a +2. And therefore, this is going to be copper 2 carbonate. Copper 2 carbonate. Okay? All right, I promise you just one more, but I'm going to do one more anyways. Let's do it this way, because I want to do one more. Those figure out the charges of the ones I've done aren't too bad. How about this one? What if you had a compound that was Fe2O3? That's a form of iron oxide. I was telling you earlier, 2 different forms of iron oxide. One's rust and one's this black compound. So what is that? Well, name it. Is it binary? Yes. Is there a metal? Iron. Yes. Is that metal iron in the middle of the periodic table? Yes. We've done a couple of these. We know it is. And we know iron can use a +2 or a +3. Which one is it using? Okay, important here. Here's how I figure it out. Oxygen's in the -2 group. It's always a -2. You can count on oxygen, -2. So it's -2. Now there are 3 of them. 3 -2s, 3 times -2 is, you got it, -6. That means the iron has to have a total charge of +6 to balance the -6. There are 2 of them. Take 2 and put it into 6. How many times is 2 going to 6? Okay. Three. Did you know that? Okay, good. So that means each iron must be using the +3 charge because there are 2 of them, and 2 times +3 is +6 to balance the -6 of the oxygen. One more time, quick. 3 oxygens, each one, an oxygen always uses -2. 3 times -2, -6. We gotta have a positive 6 to balance that. Nature likes balance. There are 2 ions. Each one must be using positive 3 for a total of positive 6. Okay, that is a number of problems we've gone through. Try these next problems on your own. Finish out the sheet. And there's one on here I didn't put down. One of the polyatomic ions on here, I didn't put this down, and that's CrO4. It's chromate. I didn't put that one down. It's not what I would consider one of the common ones, but if you don't know that, that's chromate. Oh, you can just look them up anyways. If there's one that doesn't look familiar to you, then look it up. Okay, getting on naming. That's over a half hour we spent on naming. That is probably the longest I'm going to spend on any one topic in the entire semester. Naming. Next is formula writing, but that is easier. Okay, much easier.